Hello everyone. Good evening. I hope you people all are fine and preparing for your upcoming exams, and hope so I am not late in bringing these videos. The intention of these videos is to give you a quick review of the topics one by one, and then taking care of the past paper questions, few questions, not every. And these PowerPoints which I have made, I can share this with you directly. You just need to reach out to me on Instagram. I'll be sharing the channel link. It's already in my already with the YouTube channel, but you can come on the Instagram and just DM, share the PDF or share the PowerPoint presentation. Okay, so let's just start with the discussion of this topic, that has been understanding the motion. And in the first video, I'll be covering about the distance, displacement. I'll be talking about the motion. I will be talking about the I'll be talking about the reference points. I'll be talking about the speed and velocity, and I'll be applying all these concepts here. Okay, let's just talk about what I mean by motion. Just ignore the right hand side. I'll be focusing here on the here. Okay, let me just set it. Okay, so what is motion? Motion is being when you are moving. Okay, moving means change in position. So you have to remember it is change in position. Okay, happening with respect to time, with respect to time, and with respect to origin. When I say origin means I am referring a reference point with respect to what you will be measuring the distance or displacement. For an example, suppose let's just look here that I am at the point A, correct? And here I moved to the point B, and someone is watching from the point O and point O dash. With respect to O, I am closer, right? And with respect to O dash, I am pretty far away. Okay, so what is the distance traveled here by O dash with respect to O dash? Okay, and the distance traveled with respect to O, even my position is different with respect to O and O dash. That is being taken as your motion. And what are O and O dash? O and O dash are being your reference points. These are your reference points. Correct? So that is being about the motion. When you talk about to understand the distance and displacement more, let's just first focus on to the two quantities, what we call as the scalar and vector. When I talk about the scalar which has only magnitude, correct? Magnitude means the value, like with the 10 meter, 20 seconds. These are being called as the scalar quantities. When I talk about a vector, what is a vector? Which has magnitude as well as direction. Means if I say 10 meter north and if I say 10 meters south, okay, so 10 meter north and 10 meter south, the magnitude is same, but what is different? It is the direction is different, and hence these two quantities would be treated as the different ones. Now when I talk about the examples, the scalars example is distance, speed, time, mass, temperature, and examples of vector are displacement, velocity, force, and acceleration. Okay, now let's just move quickly towards the distance. What is the distance? Distance is the total length of the path. What is distance? The total length of the path. Correct? Traveled by a body. That is called a distance. It is a scalar quantity. It's SI unit. If I talk about SI unit means I'm talking about the standard unit. What are the another units? You have kilometers, you have centimeters, you have millimeters, etc. Now, maximum time the students do not remember or they forget how to convert your kilometers into meters, centimeters into meters, or millimeters into meters. Now, just remember your 1 kilometers, kilo is 1000, so it is 1000 meters. When someone says 1 cm, c is centi, centi means 10 to the power minus 2. Okay, when someone write millimeter, m stands for milli, milli means 10 to the power minus 3 meter. Okay, now here For an example, suppose you start from here. Let's just say at the point A, you covered 10 meters here, then you went 20 meters here, and then you went 30 meters here, and then you go 40 meters here. So what is your distance? I'll just add up 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, that is 100 meters. Okay, this is your distance. Okay, so length of the path traveled by a body. Let's just move further and talk about what is displacement. Displacement, first of all, it's a vector quantity. Do remember, means direction matters, and it is the shortest path. It is the shortest path. Now, shortest path between what? Between initial point and final point. Between initial and final point. Now, what I mean by that, suppose you went from A to B covering 20 meters, and then you covered up 40 meters in this direction. So what is your initial point? A was your initial point, B was your final point. So if I can calculate A to B, right? If I can calculate A to B, that becomes my displacement. Now it forms a right angle triangle, so I could use Pythagoras theorem. Okay, Pythagoras theorem to find out the AB, that is the displacement. Displacement is measured in meters. What are the another units? Another units are kilometers, we have centimeter, we have millimeter. Okay, now do remember that what are the directions you take care of. Always remember that directions are being here regarded so as the sign conventions. Usually we define our directions as east, west, north and south here. Okay, so east on the right hand side positive, west is negative, north is taken in upward direction, so positive and negative. If you people learn already have learned about drawing the graphs, so you already know. Okay, so what you know, you already know about this, right? That towards the x direction, what you are taking positive, the leftward direction is negative, right? So after understanding this one, let's just move towards this question here. And what does this question says? Let me just have it here. Okay, so what is the total distance Alex walked? Let's just focus on what we mean by the what the question is. Alex walks around the school playground following the different directions, 10 meter east, then 10 meter south. So for that one, first of all, I need here 10 meter east. Correct? This is 10 meter east and then 10 meter south. Okay, so you have 10 meter south and another 10 meter east. So focused again 10 meter east. So reached again the initial position and then 10 meter south again. So from here, so he covered back the 10 meter south again. So you have, now then you have 10 meter south again, sorry, here going down. So you have 10 meter south again. Okay, and then 15 meter west and 10 meter north. Where is the west? If I talk about east, west, and then you have north, and then you have south. Let me just talk about it again. Okay, so guys, let's just move, apply these concepts. Alex walks around the school playground in the several direction. So let's just say he started from point O. So you have 10 meter east, correct? Then the 10 meter south. So going downward. So that is 10 meter south, correct? Then 10 meter east. So again 10 meter east reaching here and then 10 meters south again. So going downward 10 meters south again, correct? Then you have covered 15 meter west. So there is 15 meter west. Okay, 15 meter west and here it is 10 meter and then 10 meters north. So here you are reaching 10 meters north. Okay, just ignore how I'm drawing. Okay, 10 meters north. So you reach somewhere here, correct? Okay, and finally 5 meter west to reach the playground. And 5 meter west to reach the playground. So it is your 5 meter. I hope we are clear. Now it says what is the total distance Alex walked? You just need to add 10 plus 10, 20, then 30, then 40, then 55, then 65 and 5 meters, so 70 meters. Okay, then we talk about what is the resultant displacement. You just choose your what is your initial point. Here is the initial point. Okay, and if I talk about this point, this becomes my final point. Okay, so when I use this, so I would be covering up this. Okay, so this is my displacement. Now how would I be finding it out? I'll complete my right angle triangle. Correct, so this is my 10 meter. I know that this is 5 meter and then plus 15 meter. So I got a triangle where my perpendicular is 10 meter and the another side is 15 meter. Correct? So I would use my Pythagoras theorem to find out the displacement. It is 10 squared plus 15 squared, and that would gives you your answer. Okay, I hope we are clear with this question. Okay, now after understanding this one, let's just this has been already been solved here, so you can go through it. Okay, now you can try this when you can take the screenshot and then go ahead to find out the answer to this to solve this question. Okay, what is the total distance and what is the resultant displacement? So this there is an answer to it. Now let's just move ahead and talk about what is speed and velocity. Okay, so now when I talk about the speed and velocity, do understand that there are two things when we are defining about the motion. Even when we have defined about the motion, let's just talk about what those are before I move to the speed and all, speed and velocity. See, there are, when I talk about the motion, there are two kinds of the motion. One is a uniform motion and another one is a non-uniform motion. I'll just first discuss about uniform motion. Uniform motion means when you are covering equal distance in equal time. Okay, when you are covering equal distance in equal time, that is being taken as your motion. So what is the distance per unit time called? That is called speed. And specifically, if I talk about speed, speed is going to give you how fast an object moves. It is going to give you how fast an object moves. It is going to give us what is the distance traveled in the given time. Okay, that is being taken as your speed. Let's just focus about the speed formula. What is the formula for the speed? If I talk about the formula for the speed, speed is distance per unit time. There are two kinds of the speed. If I talk about, one is the instantaneous speed, that is being given as distance divided by time. Correct? And then we talk about the average speed. If it was a normal class and a normal video, I would have discussed what we mean by the average speed in detail and why we require average speed. Number of students do not remember or even do not know why we are calculating the average speed. So, but anyhow, if you want to know, just drop a comment. So what is the average speed? I will be talking about it is the total distance over total time. Okay, the total distance traveled by the total time, that is being taken as your average speed. Now the question, the example is here. If you travel 100 meter in 10 seconds, means now your distance is 100 meter and you are covering the 100 meter in 10 seconds, then it is 10 meter per second. So your speed is being 10 meter per second. How would you write down meter per second? Write down meter per second this way. You write down meter per second, meter second inverse this way, or m/s. All these are being the ways to write down the meter per second. Okay, now let's just move ahead and we talk about the velocity. Now if I give a statement that a person A is moving 10 meter per second, have I been given the direction? Do I know in which direction it moves? If after 1 second I want to find out this person, I am not able to find out. Why I am not able to find out? Because the direction is missing. This question mark carries that question, that direction is missing. So when you talk about the velocity, you are giving the speed in a particular direction. What is the speed in a particular direction? So what velocity is? Speed with direction. What is velocity? Velocity is speed with direction, and it is also giving us that how fast and slow an object is moving in a particular direction. Okay, in a particular direction. Now the same way, when we have discussed about the formula for the speed, the same way we will be talking about the formula for the velocity. Again, instantaneous velocity, which is displacement over time. And when I talk about the average velocity, here we talk about the net displacement divided by the total time. Now do remember, the total time involves every minute, every moment, every single second when you are moving from A to B. Suppose you are understanding the motion between the A to B, then even if you have stopped in between, you calculate, you consider this time. Okay. Now if I say, let's just say 5 meter east and I say 5 meter west, are the two same things? I'll say no, because the direction matters. If I say 5 meter per second east and then I write down 5 meter per second west, so do you think that the both velocities, the both speeds are same or the velocities are same? No. If I talk about the speed is 5 meter per second. Okay, the magnitude is same, but as soon as you put the direction along with it, these two quantities becomes different one, because 5 meter per second is plus 5 meter per second because it's in the east direction, and as per the sign convention which we are taking, it is minus 5 meter per second, which has been in the west direction. Okay, let's just talk about what is the difference between the speed and the velocity. If I talk about the speed and the velocity, the difference between the speed and velocity, simple. Speed is a scalar quantity, velocity is a vector quantity. That is the one thing. Speed is measuring distance per unit time, it is working with the displacement per unit time. As your distance cannot be zero, speed of a moving body cannot be zero, but velocity can be zero. How? Let's just start. You are moving, you are at point A and you move here at 5 meter in the forward direction in 1 second. Then you come back and you are covered 5 meter again in 1 second. So now what is my net displacement? If I talk about my net displacement here, it is 0. Why? Because I reach again to the my previous you'll say my initial direction. So net displacement becomes 0 and hence my velocity could be 0. Okay. Now if I talk about the examples here, just ignore. Okay. So when I talk about the examples here, let's just say the body is being moving at a speed of 60 kilometers per hour. This gives you the speed. But if I write down 60 kilometers north, then what we have here, we have the velocity, right? Because I have given up the direction here. Okay. Now, why it is important? Because it helps us in understanding the transportation, the sports, the science and engineering. This does not mean that you have to remember as per IGCSE, but it is a general thing. You must know why you are calculating the speed, why it is required to work with the numbers here. Okay, let's just talk about the summarize. We already worked over that. Speed means how fast it moves, and velocity, when you talk about velocity, is gonna give you that how fast and in what direction. That is about the speed and velocity. Let's just quickly work with the calculating the acceleration part here. When I talk about calculating the acceleration part here, so what is acceleration? Very quickly, the rate of change of velocity. The rate of change of velocity is called acceleration. How do you represent acceleration? A. You use delta V by delta T. What is delta V? That is the change in the velocity, and that is V minus V naught by time. I could use delta T or I could represent the time by T. Now what is V? V is my final speed, or you could say my final velocity, and V naught is my initial velocity. Correct? V naught is my initial velocity. So after understanding this much about, let's just move here focused. I'll give you just 1 second. Okay. Now, when I talk about A is equals to delta V by delta T, here what is being the units? Delta V. Do remember, if V is being having a unit of meter per second, delta V is also having the units of meter per second. So acceleration is being having the unit of meter per second, which is going to give you meter per second square. Okay, and here acceleration is a vector quantity. Acceleration is a vector quantity. Now the question is, what is the direction of this acceleration? Acceleration acts in the direction of the change of velocity. If suppose you are moving in A, let's just say 5 meter per second east, and then you moved here and you have 5 meter per second north, right? So this is the direction where you have V, and here you have the V2, right? Okay, if I could find out the change in velocity, that is delta V, how could I use that? I would be using the subtraction of the vectors to find out V1 minus V2, or this is my V1 and here it is V2 is my final. So if I find out V2 minus V1, then that the direction in which the velocity changes, that would be my direction of acceleration. Let's just talk about it, how we do that. This could not be a part specifically, but still I am doing it because I want to show that how we will be finding it out. Okay, now if V2, what I need, V2 minus V1, can I have V2 minus V1 as V2 plus minus V1? So if V1 is positive in this direction, where is minus V1? Minus V1 is going to be in this direction. So you have V2 and then you have minus V1, correct? And if I talk about the resultant here, then it would be V2 plus of minus V1, because resultant means that you are adding up the two vectors here, correct? That is V2 minus V1. You can skip this part if it is not required, because it is not required at IGCSE level. So you have V2 minus V1. So again, the magnitude remains the same, that you have V2 squared plus V1 squared to find out the net change in the velocity. But the direction is this, the angle, the direction in which your arrow is being denoted here, correct? At this angle. So the velocity is changing in this direction and hence your acceleration changes in the same direction. Okay, after understanding this one, let's just move focused about one question. A car goes from 0 to 20 meter per second in 4 seconds. What is the acceleration? To understand that, you need to find out what is the velocity, initial velocity, and what is the final velocity. Correct? So we have A as V minus V naught by T, right? What you have? 20 minus 0 by 4. So you have 5 meter per second square, right? That is the acceleration. That is the basic thing. Before I move, I need to first discuss that acceleration could be positive, acceleration could be negative. Okay, let's just talk about acceleration could be positive. Positive acceleration when you are moving in this direction, the positive direction. Acceleration could be negative when you are moving in the opposite direction. There are two more words which we called as the word acceleration and the deceleration. Okay. So when you are speeding up, you are accelerating, then V is greater than V naught. And if you are deceleration, then V is less than V naught. That means you are braking. You are braking. It is not B-R-E-A-K-I-N-G, it is B-R-A-K-I-N-G, means you are pulling up the brakes. And here you are speeding up. Correct? You are speeding up. Now, if bike slows down from 10 meter per second to 0, right? So what is the velocity? The final velocity is 0. What is the initial velocity? That is 10. Final velocity is this. Let me just change it. Okay. So we have V and here V naught. So what is my acceleration? V minus V naught by T. What is my V? 0 minus 10 by 5. So here it is minus 2 meter per second square. It simply means, Okay. So what does that mean? That it is slowing down. Negative answer here represent that I am slowing down. Okay, so this is a certain glossary which I have placed here, so you can go through it. Again, if you need all the 3 PDFs which I have used, you need to reach out on Instagram and DM me to share all these PDFs with you. Okay, and you will get the PDF. Okay, before I move further, let me just cover up few questions here. Okay, let's just talk about this question. An athlete runs at a speed of 8 meter per second for 10 seconds, then at a speed of 6 meter per second for 12 seconds, and which calculations give the average speed? I hope now you remember when I talk about the average speed. Average speed is total distance over total time. But now the thing is, do I have the distance? Yes, I can calculate the distance because I know that it is speed is equals to distance over time, right? So distance is speed times time, means 8 times 10, that will gives me the total distance. Then you have speed times time, that is the another one. And what is the total time? That is 10 seconds plus 12 seconds. That is 22 seconds. Let's just find it out. It is your B option. Okay. After that one, let's just move to the next question here. This is the graph, and probably I'll be coming up with the graphs in the next video. Let's just talk about this question. Now, this is the first question, but here I am focused on this one, the second part of the C. Here, a train travels with a constant velocity. Now, understand, constant velocity initially means acceleration is 0, but it has given you the initial velocity 56 meter per second. Now, the mass of the train is given. First of all, state the difference between the velocity and the train. This is your homework. You can very quickly do that if you have heard the video, you have gone through the video completely. I am focused here on this one because I haven't done kinetic energy yet. I want to calculate the distance traveled here. So it has already given me that there is an acceleration. So I am taking the value from the previous part, which you have to take care. So what is the acceleration? It is plus or minus. Do drop the comment whether I'll take this as positive acceleration or a negative acceleration. So it is minus 1.2 meter per second square, right? Because it is deceleration. What is the initial velocity? V naught. V naught is your 56 meter per second. I need to find out what is the distance traveled if it is coming to rest, means your final velocity is coming to rest. So here you can use your formula booklet, but here you are going to use v squared minus v naught squared equals to 2as. This equation you are going to use it. Okay, so what is my v? V is my 0, so 0 squared minus v naught squared, that is 56 squared, equals to 2. A is minus 1.2 and then multiplied by s. Okay, so what I am gonna find out here, my answer as minus 56 squared equals to minus 2.4 times the displacement. So negative sign gets cancelled. I get 56 squared and then divided by 2.4. I will be getting my distance as 1306.66. Okay, so it is, and your answer has to be in meters. In these 3 units, you must get the units right here. Okay, so when you talk about 1306, even if you write 1306 meters, that also works. Here I am done with my first video, and please stay tuned as you will be getting more videos on the same channel. So please do like, share and subscribe.